All right, welcome back. This is Algebra 2. Today we're still looking at solving equations, but now we're looking at something slightly different. Okay, these are called inequalities, and let's set that up with this word problem here. This word problem tells us that Alan is loading a pallet with boxes that each weigh 45 pounds. The pallet can safely support no more than 900 pounds. Okay, that's wording we're going to talk about. And what we're being asked to do is find how many boxes he can safely load onto the pallet. Well, remember, we always start with the total amount. And we know that the total amount that the pallet can hold is 900. Remember, your total is always on the right side. Well, how do you get to 900 pounds? Well, we know we're stacking boxes. And when you stack boxes, each box is 45 pounds. But that's each box. I'm not just stacking one 45-pound box. I'm stacking a bunch of them. Because we're doing it over and over, I'm doing more than one of them. We need to multiply that with the amount. We don't know how many, so we're going to use our variable x. Now, there's one keyword in this, or key phrase in this problem. It says no more than. Well, that means it's the opposite of more than. In other words, what we're looking at is we know that the amount, the weight, has to be less than that 900. We know it's not allowed to be greater than 900. Well, it can be less than 900 or it can be 900 itself. That means we need the little equal to part under this equation. Under this inequality. So by reading through these, it's still the same idea of creating some sort of equation or inequality. But now the main thing is you have to pay attention to the wording to know what symbol to put in between both sides. Knowing that, let's talk about some things that happen. On that last problem, if you were to end up solving it, I guess let's finish this. If you were to solve it, you could divide by 45 on both sides and find that x, the number of boxes, must be less than or equal to 20. So boxes less than or equal to 20. Okay, I'm just not going to write the equal to part there because that's a lot of extra work. So we know the boxes have to be less than 20. Realize what that means is you can have 20 boxes. You can have 15 boxes. You can have 10 boxes. But you're not allowed to have 21 or 22. It has to be a number less than 20. What that tells you is our answer is a range of values. For example, if we wanted to graph exactly what we just looked at, x is less than 20. Okay, maybe we make this that x is less than or equal to even. Well, if we do that, we can look at a number line of graphing that. And if we're at 20, we know we're allowed to have 20, so you fill in your circle when it has the equal to part, the line underneath the symbol. But we want to be less than that as well. Realize the values that are less than 20, such as 19 and 18, those would all be on its left side. So you draw your arrow that direction. We did not draw it to the 21 or 22 because those are bigger than that value. You can look at that for other examples. For example, if x is greater than 6, here's my 6. We want to be greater than that, so go towards the values that are greater than 6. That'd be the right side. Notice your symbol here does not have a line underneath it. That means we have an open circle is what that is called. It means you can get infinitely close to 6, but you're never actually going to touch 6. You can have 6.1, 6.001, but you never get to 6 itself. Looking at the two problems on the bottom, same idea. X is less than negative 3, so you have less than. There is no equal to part, so it's an open circle. And make sure your arrow goes to the lesser values. One thing you can notice as well is these symbols actually look like arrows, right? That is an arrow going towards the left. That meant my arrow goes towards the left. Looking at this last one, x is greater than or equal to 0. Again, you have the equal to part, fill in your circle. That means you can actually have that value, and we can have every value right of it. Well, graphing these things on a number line is great, but the main practice that we need to have down is solving. And the nice thing about solving is it's actually practically the exact same as solving an equation. For example, on this one, I'm going to add 12 on both sides first, and then I'm going to divide by 10. However, when you go through this, though, there is one very, very specific rule. That specific rule is as follows. If you multiply or divide by a negative, then you must flip the inequality sign. Well, let's break down that rule. That's a very, very important rule for this process. Okay, let me move that up a little bit first. Okay, there's our rule a little bit higher for us, so now we can see it. The rule states if you multiply or divide by a negative, you must flip the inequality sign. Well, this problem's a good example to look at because right now we're dividing by 10 on both sides. And what a lot of people do is they look at that negative that's on the 70 right here, but we need to pay attention to the wording of this rule. The rule says you need to multiply or divide by a negative. Well, notice what we're dividing by. We are dividing by a 10. I don't care about the value on top. I care about the value I am actually moving. If I am multiplying or I am dividing by a negative, it would flip. But in this case, we said that the 10 is positive, so your inequality sign actually stays the same way. Let's look at an example that it would actually change on now. Let's compare that to this problem after it. Again, you still can go through that same process, get rid of whatever adds or subtracts first generally, and then divide or multiply by whatever is in front of it or under it. So we can divide by the negative 2, and notice what's happening. Now you are dividing by a negative. Because you are dividing by that negative, what ends up resulting is the sign flips. Your last step then, just find that value, and now you have your final answer. It's only when you multiply or divide by a negative that it changes. Let's look at another example, just a more complicated one. So this one's just in here just to remind us of some of those solving processes and different key things like that. So on this one, again, parentheses, we always get rid of those first. Let's distribute 6 times 2, 6 times negative 5. Be careful with your signs. I have seen that mistake come up a few times. I believe that was a 38 there. One thing I want you to be careful about is notice there is a variable, there is a y on both sides of our line in the middle. When there's one on both sides, we need to get them to the same side. It doesn't matter which one you move. I generally just stay consistent. I take the one on the right side and move it to the left. But since they're on different sides, we need to understand how to move them. This is the biggest mistake I've seen this year. When you have them on both sides and you need to move one to the other side, you always change its sign. So if I have a negative 30y on the right, I can add 30y to both sides. What happens is that 30 and 30 on the right go away. But we're now moving it to the left side where it can combine with its like term, giving us 25y. Everything we did not use just comes down with it. And now it's just like a problem that we have done before. Yes, there's extra steps, but there's steps that we understand. There's steps that we have done before. We know how to distribute, and now the mistake we're cleaning up is when to move variables to the other side and how to do that. We'll continue to talk about that idea throughout this class, so let's keep working on it. That is your entire video for 2.1, solving linear inequalities.